Hello, everyone. My name is Alper. I am the CEO of Oncolabs and BASSG. We have basically, I will be doing a live demo, so if you would not use the Wi-Fi, it would be good. It would be less grainy. All right, so we have created a project called Project SenStar, and we are trying to challenge the controls world with basically the word order with the power of Project Haystack and SkySpark. So the current status of our industry is there are large 5 companies. I spell them in my native language. And what it is happening right now is that the source code of the code where the real-time controls is not portable between any of those systems. So that is a problem. So if we want to change, when we change vendors, we are not able to port the code that is in the control system to another brand. And that is hampering our progress on the smart building space. So what we have done is I created Project SenStar. It is a project from Brian Frank, and both of them, Sedona and Project Haystack. The way we merged it is we abstracted I/O and AVs and BVs with Haystack model. And we embedded into basically to the controller. So what does this enable? It enables us to be able to move the industry forward for doing graphics based on tags and mobile app based on tags, or maybe machine learning based on tags. John is maybe automatic would be with you. So it also changes the architecture. Architecture is currently on a 3-tiered level. We have microcontrollers, we have gateways, and we have supervisors, and we finally put the whole stack into the cloud. But what we have done is we have integrated SkySpark right within the controller. So I'm going to do a live demo of a project. Hopefully, my Wi-Fi will work well. What you're seeing right now is a master instance of SkySpark, and we have a view framework. And within this instance, we have rooftop units and VAVs. And I can select any of the rooftop, and it's using ArcBeam communication to the other Haystack and listing the points, and you can see like basically the overviews right from the view framework. We have written an app called Visualytic, and Visualytic is basically block programming to create our spinning fans. And this is basically getting the floor plan data through ArcBeam within the small instance of project. What we can also do is the navigation on the right side is literally generated through the ArcBeam model. And what you're seeing is the Visualytic. The JSON file is sent to the master through ArcBeam. Just to put this in context, I made a little chart of how the system is working. So we have a rooftop unit, and within rooftop unit, we have Visualytic, which has the graphic. It's pushing the data to the master, and the Visualytic is reading the JSON file and the Haystack data right in the master. So for the first time in our industry, we are highly close to getting to plug-and-play controls. Why do I say that? The only thing that we need to tag as to get a rooftop unit into an automation system is the site-ref tag. For a VAV, all we have to do is give the site-ref tag and the air-ref tag for the VAV where the rooftop unit is coming. So we can literally drag and drop to VAV to a rooftop unit, and it would be part of the network. The graphics, sparks, alarms, everything would be automatically commissioned. All right, so the second part of the system is that we need to do resets. We do resets in building automation. What we do is we try to read the overall views of the system. And what I will demonstrate now is how we do the resets within Sandstar. We have written an xquery function, and this function right now, this is a debug version of it. What this is doing is it's saying, return me the zone air temp sensors that are attached to rooftop unit 11, and it returns the points to us. And what I can do is I can, just for debugging purposes, I can look at the historical data for the last 15 minutes. So you can make these data calls, max, average, and all that. And right now, if I do null, it is going to collapse that call into a single cell. This single cell, I can read it from the Sedona layer. So the way it works is, in Sedona layer, we have a Haystack client, and it's authenticating to the local host of the SkySpark instance that it is running. Then it is jumping to the master project, doing an eval call for the function, and we are getting that value. So just to put that a little bit more in detailed context, I made another cluster call explainer because it can get convoluted. So we have basically a rooftop unit. Rooftop unit is looking at the AirRef tag for the VAVs that are matching for its filter, then jumping to the zone temperatures, getting the average call, returning it to the master, and we are making that data call within the rooftop unit. So rooftop unit is a client to the master instance. Master instance is doing an xquery call to the whole network and getting that single data cell. And by doing that, we can actually easily roll up data based on tags. That is the xquery Haystack client. So if we look at the architecture, Haystack client is within Project Sandstar, where the Sedona is running. It is connecting to the local SkySpark and jumping to the master instance, getting that data back to the client and linking to the block programming within Sedona. So Sandstar is done. On Visualitic, I wanted to demonstrate one more thing. We do have a DVR function, and Visualitic is extensible. So the whole thing is done with block programming. So it loads the libraries. We can just go to one of the units, and you can play back. If you wanted to link the sparks on a rooftop unit, you can actually animate that and play that data back as well. So we go to RTU9, and we can select the date, go back to a date, and I can play that date back. So you can link not only real-time data, you can actually link Spark results or Spark, something is sparking, you can animate that as well. And this data is coming from, the data is in the controller. It is not in the master instance. All right, so next thing, we are going to go into Mobilytic. So we have Visualitic and we have a Mobilytic. So I'm going to try to connect to my phone. Hopefully the internet will allow me. And let's switch. All right. All right, so Mobilytic is a native Haystack tool. It is written in Flutter. So what you can do is you can do overview dashboards. I can drag and drop a chart and refresh here, and the chart is there. And then you can link your chart to an Exxon function. So it's as simple as that. And from here, we can do schedules. So I can edit a schedule right from here. Yeah, so I cannot do that. Yep. We can go to Sparks. We can go to monthly view. I can filter. You can see it in full. I can filter any of the rules right on the phone. I can literally control my whole building right from here. We can do arc nodes, so I'm going to open up the AHU outside damper stock. You can take a picture for a comment. So we can take a selfie, maybe. It will be, and when I put that in there, you can put a comment, and we can go to the arc node. It was AHU1, right? Damper stock. AHU1 outside air damper stock open. And the picture is there. And you need to have the URI in it. So you can add your nodes, and you can close the ticket if you wanted to. The other feature that we have within the Mobilitic is I have way too many panes open to do a demonstration. I think I closed the screen somehow. There you go. All right, so what we also have is we have, you can drill down into units. So I'm going to rooftop unit 1. You can look at it in a monthly view. You can scroll down to the right, and this is filtering only the arc nodes that are on that given equipment. Scroll to the right, you're seeing the live data of the points. Scroll one more time. If you had Sparks, it would show the Sparks only for that given equipment. You have a barcode, and the barcode is coming delayed. So the barcode is basically is the rec ID of that equipment. And what we can do with this is you can print it onto the equipment, and we can go basically, I'm going to take it to the home screen. Go to menu and scan QR code. And it will jump to that unit. And you can build other QR codes for doing historical rights and other things as well. The Mobilitic is also capable of doing NFC tags. You can create jump views. You can create arc nodes. You can do his rights. NFC tags are really cheap. You can buy it on Amazon, 100 of them for like $20. You can do tenant overrides if you wanted to, right through the mobile phone. All right, so the last part. I've been involved with LoRaWAN lately. It is a really cool, I think, wireless technology. Has anyone heard of LoRaWAN so far? Okay, great, awesome. All right, we have integrated LoRaWAN from MileSite. And what we have done is, what you're seeing is a LoRaWAN power meter sensor installed at my house 4 days ago. And it is directly communicating to SkySpark. And the way we achieved it is, I'm just going to go very technical really quickly because it's kind of cool how we achieved this. LoRaWAN has basically, you have a gateway. And the gateway, you define your devices. And you need to basically, on the device name, we are giving the hardware manufacturer's device in it. And it has a device UID that is unique identifier. It's like a MAC address. And in the application layer, what we do is you basically create decoders, encoders. And decoders are encoders almost like LAN snippets if you had worked with LAN in the past. They are just JSON, binary objects, converted into JSON. Hardware level communication converted to JSON. And what we're doing is we're pushing the data to SkySpark from the gateway. And within the SkySpark, we are doing something opposite. what we are doing is we are defining a port within the connector where we listen to the MileSite packets or LoRaWAN packets coming into SkySpark. And we have a password, so it's a little bit more secure. And within the builder side, we are making a data call to the MileSite gateway so that we list all the devices that are under that gateway. And for each device, it is hard-coded, and all the points that are inside it is hard-coded. So you just drag and drop, and it works. So no cloud for LoRaWAN. It's directly into SkySpark, and you can do indoor air quality sensors, door sensors, water leak, anything that you can think of. And we also designed a thermostat with MileSite recently. All right, that is the technical conclusion. I'm going to talk a little bit about the business side of things, how I am thinking about achieving a change in our industry. All right, so I'm announcing basically Sandstar Foundation. The goal is to bring OEMs utilizing this technology and build hardware along with us. Sandstar as an engine is already completely open source, and everything else will be source available to founding members, and we are hoping that we can kickstart other hardware manufacturers to have all the stuff that we have written there. There's a lot of stuff in there. That they will be able to get it, compile it, and they will have to buy the SkySpark points from the Sandstar Foundation. And it will basically be hardware agnostic, and we will basically control and maintain all this code base over it. And for that, because it is distributed and community-driven, as a final part, we created an NFTs, and we created a single NFT, and that is Big Boss, and he's the creator of our universe. And I had given that to Brian last month, and he has that NFT currently. And people will be able to join to this through NFTs, and you will have that as well. One last thing, we do write a lot of freebie apps, and on StackUp, we recently wrote NHaystack Import Enhanced. It is open source. You can download it, play with it, and there's a video on how you can use it as well. So that concludes my speech. Any questions? No? Let's go lunch.